welcome to Wisdom Wednesday. I'm your host and baker influencer, Richard Charpentier, certified master baker, and also the host of Tuesday 10 at 10. The format of Wisdom Wednesday is to have bakers such as myself share tips and knowledge and education so you can learn a little more about things you didn't know. So today I'd like to take the time to talk to you about baking powder and also the rate of reaction and why it is important for the bakers and the bakeries to know more about it. So in the bakery world, we've always been bakers always looked for ways to leaven their bread to get volume out of the breads. The first incident or accident was when the ancient Egyptians, left an old piece of dough, and all of a sudden the next day, with some water and some grains, they had volume. So the yeast had basically eaten the food and generated CO2 plus alcohol to expand the piece of dough. And it was not until 1843 that a British chemist was able to invent baking powder for commercial usage. The principle of baking powder is technically to leaven, create CO2, but now versus a biological reaction where the yeast are the one producing the CO2. Now it's an acid-base reaction. You have a acid or leavening acid and coming in different ways. And at the time, the first one was tartaric acid, the cream of tartar that was coming from the leftover of grape or wine making. And that acid will react with baking soda, which is the base, to form CO2 and expand your pound cakes or your muffins, etc. So today we've come a long way from the basic baking powder. And I want to talk to you about the rate of reaction. The rate of reaction is how much time it takes for a chemical reaction to happen. So, and in the world of baking powder, most of us are buying baking powder without even thinking what is in my baking powder, and it's sort of one size fits all. Most common commercial baking powders today are dual acting. What does that mean? It means they have two leavening acids and baking soda and often a carrier such as cornstarch to prevent or to extend the shelf life and to make it easier for the bakers to use it. Most of the commercial today modern baking powder have a very fast reacting leavening acid in the form of monocalcium phosphate or MCP, and a secondary leavening acid in the form of either salt, sodium aluminum phosphate, or sodium acid pyrophosphate, SAP. So, and depending on where you buy it, they react at different rates. But what I'm talking about is the rate of reaction. Every time, in order for baking powder to react, all it takes is moisture and heat. So think about it. You take your muffin mix, add all your dry ingredients, and now you're putting your liquid. And at that time, as you start mixing and sharing the water around the dry ingredients, the rate of reaction will start. So that means the first one to react will be monocalcium phosphate. Monocalcium phosphate would produce all of its CO2, or not all of its CO2, at least 60 to 70% of its CO2 within the first 2 minutes of the batter being put together. So, and also I've learned as a tip that if you wanted to change the viscosity or you were depositing a batter and you didn't get enough flow, adding a little bit of monocalcium phosphate with a little bit of soda will allow to change the viscosity of your batter. So that's always a good thing to try. And you don't want to change your pH too much. But 60% of the monocalcium phosphate is going to react. So then comes along the other acids. And as you can see on this slide, so it shows how much through the curves the acids are reacting within the first 10 minutes. The one that's really jumping really high up, as mentioned earlier, is monocalcium phosphate. It's losing all of its CO2. A reaction is happening up front very early on. As you can see, for a salt, a sodium aluminum phosphate, usually it's between 20 to 40%. As for sap, you will have about 30 to 50% of that being reactive. And why does that matter to bakers? Well, as you're a baker, time is very important. And most of the bakers, once you're running a production facility, you can't just make one cupcake at a time and bake it. So often we have to scale up and we have to run batches that are much, much larger than what someone would do at home. So, and then your batter will be sitting there for sometimes 10, 20, up to an hour until you can be done. So that's why it's important to start thinking of how to think of baking powder through the rate of reaction based on the end usage and how you're going to use it. Because any batter that you're leaving sitting on the floor, and especially if the baking powder you have as sap and salt and the MCP is dual acting, you would lose a lot of the CO2 reaction up front. And if it sits there for an hour, so you start seeing a change in consistency, a change in volume in your cakes. And what we're trying to do every day and what bakers are really working hard to do is to do the same good quality product day in and day out. So learning about the rate of reaction can really help bakers better plan for what they're trying to do. So let's look at the second slide. As you can see on this slide, it shows the rate of reaction over an extended period of time at about 80 degrees. And the same principle, but if you look at the graph closely, you're going to see that once you push within the first 10, 15 minutes, you're losing most of the CO2, about 50% of it is being lost, having the batters sitting around. So how can you counter that? Well, the best I always said is to start thinking, how can you make your own baking powder? And making your own baking powder is not as difficult as it sounds. There's a lot of fantastic information on the website, on Bakerpedia, where you can learn about neutralizing value, the different rates of reaction. But now let me tell you, so you could think of salt, sodium aluminum phosphate, for along with your MCP if you're making your own baking powder. But just know that there are two versions of it. There is an hydrous and an anhydrous, and one is faster than the other. So, but they're quite stable. But as we hear a lot of people trying to remove aluminum or not, the second choice for leavening acid will be in the sap family, the sodium acid pyrophosphate. But again, they're coming into different rates. You have one that is very slow, and the very slow sap is often used for refrigerated or frozen dough, because as you can see from the previous graphs, it's not going to react right away. And that's what you want for those type of dough. That would be wrong to have a lot of fast reacting right away. So, and then you have a mid-size, it's matching a little bit with salt, which is fairly standard in most of dual acting baking powder. And then you have the faster sap, which is higher up, which could be used for biscuits and other different products. And all of those sap and salt do have the same neutralizing value, except now the rate of reaction, how much CO2 they will release up front, will vary based on the type of grade baking powder you're getting. So remember, baking powder is just like yeast. If you don't have a good yeast, you're not making a good bread. So understanding and trying to understand as best as you can and educate yourself with baking powder and the different options you have, you could easily take your production, if you're making muffin, and make muffins and refrigerate the muffin for 2 to 3 days versus making a batter every day. So, and it's about trying to minimize how much of your leavening acids that you're losing up front based on the temperature and time that you're leaving the batters on the floor. So I hope it was a great Wisdom Wednesday for you. And also, I would like to remind you that on Thursday, tomorrow, there is a free live seminar on Bakerpedia that you should definitely join. It's going to be talking about vital wheat gluten, and it's an essential protein used by all bakers around, and it's in flour to make bread and to build a structure. And they'll be talking about alternatives and ways to find better ingredients or ways to not use it as price goes up or supply becomes scarce. So please sign up. It's a free conference. I definitely recommend for all of those of you watching here. And I'll see you another time. And thank you very much for watching. Take care.